Hi guys, we're going to talk about the ambiguous case today. Hopefully a lot of you guys recall the law of sines from your geometry classes back in the day, but the ambiguous case is when we're given a angle side, or sometimes it's labeled as like this, SSA, or sometimes written in reverse, which, we could call it the ASS case. So, when we have this ambiguous case, we're going to actually see some situations where we could have no solution, one solution, or two solutions. That's why it's called ambiguous, because right off of this initial setup, I actually can't tell right away whether or not what type of solution I'm going to get. Now, there are certain scenarios we could talk about with this side being smaller than this side, whether or not we'll have one, two, or no solutions. We'll cover that a little bit later on. But looking at this problem, this is not a congruency postulate or theorem. Therefore, I can't say, oh, it's definitely going to be this solution, or it's just going to be one specific triangle. And this is going to show up because when we use the inverse sine function, I could get one or two answers for this angle. So, enough talking about it. Let's get into it. So, given this problem, I have angle A is 57, side A is 33, and side B is 26. This is just a generic drawing. I always draw my triangles like this. Probably most of you guys do the same way. Does not necessarily mean that angle B or angle C cannot be obtuse. In this example, they will be acute angles, but don't get in the habit of, oh, I drew it acute, so it has to be acute. That would be a very easy misconception that one can make. Applying my law of sines, I can write 33 over sine 57 is equal to 26 over sine B. Now, I'm not going to write out every single calculation, so feel free to pause the video and then do some of the calculations yourself. If I were to simplify this, I would get roughly 0.66, we'll say 0.77 is equal to sine B. Now, in order to come up with, well, what is the angle B in this case? Well, naturally, I'm going to employ the inverse sine function here. And if I take the inverse sine of 0.66077, and I would just use the answer key from here. If I do the inverse sine of, we could do inverse sine, both sides theoretically, but we do the inverse sine of this. Inverse sine, I would get angle B, and I'm just going to round to the nearest degree. Angle B is roughly 41 degrees. Now, this is why we call this the ambiguous case and why it's not clear. Angle B doesn't have to be 41 degrees. In this example, will be, but let's just talk about the algebra part. There's another angle with the same sine ratio, because inverse sine only will give me results from negative 90 degrees to positive 90 degrees. Remember, we worked on inverse sine. It shows up in the first and fourth quadrant. The other angle with this same inverse sine ratio is, we can calculate this, 180 minus 41 equals 139. And I invite you, now because we're rounding, it'll be slightly different, but I invite you to check this out. The sine of 41 is, and I'm putting equal, it's about equal because we did some rounding in this problem. But these two are about equal. So in my law of sines, if I got this ratio, how do I know if it's 41 degrees or 139 degrees? How can I state with certainty? This is where this piece of information becomes important. Sine A is 57. A triangle, the interior angles of a triangle, can only add up to 180. Can't exceed it, can't be below it. Has to hit 180 exactly. Well, if angle B was 139 degrees, that would already, 139 and 57 would already exceed 180 degrees. Therefore, angle B cannot be 139 degrees. It can't be equal to that. But angle B is equal to 41 degrees. In this problem, we are showing that we can get two solutions for angle B, but only one of the solutions is valid. Now, we're going to show some later on examples where I can get two solutions for angle B, and both will be valid. But we'll cover that in a later video. Once I know that angle B is 41, then I can proceed and solve for angle C as well as side C. Right now, I'm just focusing on what this angle has to be. To determine angle C, well, if angle B is 41, angle A is 57, I would add those two together and subtract from 180, and I would come up with that angle C is 82 degrees. And then we could go ahead and solve for side C using the law of sines one more time. Also, one thing to note before I end this video, some of you guys might have saw in geometry these fractions or proportions written in reverse, meaning the sine value on top and the side length on bottom. That's completely fine as long as you're consistent in your proportions, meaning if I always have the angles on the bottom, that means all angles on the bottom. Or I have all angles on top and all side lengths on the bottom. All right, stay tuned for some more videos on the ambiguous case.